The topic of today's discussion is how are we going to use Bluetooth communication, Bluetooth wireless communication with Arduino, and how do we convert our Arduino into a wireless device. Bluetooth is essentially a wireless standard. Okay, wireless standard means Bluetooth gives you the ability to transfer and receive information in a wireless mode. That is the first thing that you have to understand. The second thing that you have to understand is Bluetooth essentially communicates information between two devices. If you imagine first device as Mr. X and the second device as Mr. Y, information exchange happens between these two devices. First of all, let us understand why should we use Bluetooth. Later on, we'll see how to use Bluetooth. So the first point that you should understand is what is necessary for using a Bluetooth communication in your Arduino. So why Bluetooth? Now I would like to quickly revise what we discussed in the previous class or previous lab in terms of home automation. In home automation, what we did, we controlled two devices, a fan and a lamp. In the place of fan and a lamp, we used a couple of LEDs. Conceptually, both are same. Only difference is this fan and lamp should be connected by using a relay. Okay, so you know how to use a relay. This fellow will have a single phase and neutral output. So in the socket of your home, you have phase and neutral wires. So in the phase wire, I connect this fellow. The neutral wire I'll break. So in between this, instead of directly connecting this neutral wire, I break this neutral wire and I connect a switch. This is where the relay comes into picture. A relay consists of 5 coils. First one, of course, is the coil C1 and C2. I activate this coil by using a transistor. This transistor is in turn controlled by any pin of your microcontroller. Let us say I am using pin 13. Once this coil is activated, we have 3 terminals in the relay, namely a common terminal, a normally open, and a normally closed. So this is my normally open, this is normally closed, and a common line. Connection is normally established between normally closed and common line. The moment this relay coil gets activated, this contact will shift towards normally open. So contact is established between normally open and common whenever this coil is activated, and that coil is activated whenever this transistor is on. And whether this transistor should be on or not is dictated by the output that is delivered by the port pin of the microcontroller, which is in turn controlled by the program that I write. That is how the entire chain works. So this fellow supplies a 0 or a 1. Accordingly, this transistor turns on or off. Accordingly, this coil gets activated or not activated. Accordingly, this contact is established or not established. So that is how this concept works. Now this is a switch, isn't it? So now how are we going to close the circuit? So one end of the neutral wire I connect it to the common wire. From the normally open line, I take the other wire and I connect it to the neutral of your home. So whenever this coil is activated, a contact is established between normally open and the common line, which means this contact comes here. That closes the circuit. Therefore, this fan starts to rotate. Now that is the physics of how this relay works. Now, in order to decide whether this fan should be on or off, we need to send control signals, isn't it? So who is sending the control signals in our example, home automation example? You are using PC to send commands. So PC was sending commands to the Arduino microcontroller, and the Arduino microcontroller, this is sending commands using UART communication, and the Arduino received that commands via UART, and then it took a decision whether to turn this fan on or off. Now, how communication happens between PC and your Arduino? We use a MAX232 device. The MAX232 device essentially is used to, why we use MAX232? The straightforward or pseudo way of using UART is by using USB. This is pseudo UART. Using MAX232 is the actual UART, which uses the transmit and the receive pin of your Arduino. So in the MAX232, we take the transmit in. This is my transmit in. Transmit out we take and we connect to the receive of your PC, and from the PC side we take the transmit and we connect this to receive in. We take the receive out and we connect this to the receive of your Arduino. So this data goes in, this data goes out. So now we will be having a lot of capacitors here. In fact, we have 4 capacitors. Those capacitors act as charge pumps. The job of this MAX232 is to convert this 0 to 5-volt logic of my Arduino to plus or minus 12-volt logic of your computer. So this voltage translation is taken care of by this Max2. So the moment I connect this PC to the Arduino device using Max232, PC now send commands. So we used 4 commands: A, capital B, capital C, capital D, like that. For capital A, this microcontroller did something. What is that? It turned this fan on. For capital B, it turned the fan off. For capital C, it turned this lamp on. For capital D, it turned this lamp off. For any other command, it turned off both the lamp as well as the fan as well as the lamp. So that was the code that we wrote. In this example, what is the biggest disadvantage or discomfort to the user, do you think? Right. If my home automation should happen in a most convenient way, the biggest bottleneck or the issue that I have here is the PC. Okay. In order to turn on fan and a lamp, I cannot go and turn my computer on every time. Okay, that is not practically possible. And to turn on a small fan and a lamp, we cannot expect to turn on a computer every time and send commands from a computer. That is not practically possible. It's not that it is not possible. It is not a smart way of doing it. Okay, so probably using a computer to send commands may help you to learn the basic concepts of how UART communication works and how to transmit and receive information via UART. So probably for learning purpose, we may use PC. But when it comes to practical scenario, transmitting and receiving information via PC and building a practical application like home automation is not that effective. Okay, so it is not that practical also. So that is a problem here. So I just wanted to eliminate PC is my first bottleneck. So that is my first issue, number 1. The second issue that I face is the lengthy wire. Okay, even if I'm going to replace PC with some other device, I hate this entire chain of messy wire that is communicating between the controlling device and the Arduino device. This PC acts as a host now, which is sending commands. So when command is sent, we need some kind of a media. Now in this case, we are using wire. So this is a wired communication. This wired communication is always going to be a messy thing for me, because the moment some sort of a physical disconnection happens between any of these wires, there ends the communication. So the Arduino will never respond for any commands. So wired communication is always going to be a risky communication, because the moment there is a small disconnect happening between the transmitter and the receiver, the entire communication fails. No matter what is the command sent by the PC, the Arduino is not going to respond. Why it is not going to respond? Because there is no data available because of the communication failure. So there are 2 disadvantages that are available here. One, the discomfort of introducing a PC in this design. Second, wired communication, which is always a headache for me. So this is where your Bluetooth comes into picture. Okay. So now let us see what is the value addition that Bluetooth brings for this home automation example. Now in this home automation example, we are doing 2 things here. The first thing that I'm going to do is I'm going to eliminate this PC, and then I'm substituting this PC using a smart handheld device, namely a mobile phone, which majority of you are having today. So a smart mobile phone is what I'm going to replace in the place of my personal computer. So that is my first thing. So why I should eliminate my computer? Because it is very difficult for me to manage sending and receiving commands by using my computer. Every time for turning on my fan and tube light, if I'm going to turn on my computer, it is better I directly go and turn on the fan and the tube light. Okay, so that is a very easy to do. So instead of turning on the computer and then sending the command. So that is the first thing. So a mobile phone is much easier for me. It is on 24/7. It is available in my pocket. So I can easily send commands from my mobile phone. So it's very handy for me to send commands. So this is a very easy and smart thing to do. That is the first one. Second thing that I have done is the previous wired communication, which we have done by using Max232, is also eliminated in this case. Okay, whether you are using USB cable or RS232 cable. RS232 cable we use for actual UART. USB cable we use for pseudo UART. In either case, we use wires here. This messy wires I am eliminating, and I am substituting that by using wireless communication. This wireless communication feature is introduced by adding a Bluetooth module here. The moment I add this Bluetooth module to my Arduino now immediately acts as a Bluetooth compatible device. Okay, by default, my Arduino doesn't have Bluetooth feature. I need to add an external device to it. So we need to add a Bluetooth transceiver module external to this Arduino device, so that the Bluetooth now gets the power of transmitting and receiving data in a wireless mode using Bluetooth communication. So the moment you convert your normal Arduino into a Bluetooth compatible Arduino, your Arduino now becomes a Superman. Already it is a Superman only. The moment you you extend the feature of Arduino by connecting a Bluetooth module, the power of the Arduino board is multiplied many folds. Okay, so how it is extended many folds? Now the Arduino gets the power of getting information from a handheld device like a mobile phone, which is available in my pocket. So very easily it is possible for me to send information to my Arduino instead of using the most difficult way of using computer and lengthy cables like this. So the simplest way of converting a normal Arduino into a super Arduino is by connecting this Arduino with a Bluetooth compatible module. This Bluetooth compatible module gives the power of Bluetooth connectivity for my Arduino. The moment my Arduino gets that Bluetooth connectivity, then I can communicate to this Arduino as if I communicate to any other mobile device. You know how to exchange files, how to transfer files between two mobile phones, right? The same way you can pair this Arduino device and you can communicate information to this Bluetooth module by sending commands. It is also possible that this Arduino device can transmit data. It is also possible for you can send data to Arduino. Either ways it is possible. It is a bidirectional communication. So that is the power that this Bluetooth module offers to this Arduino. So the next step is how are we going to connect this Bluetooth module to this Arduino is the third thing. So the module that we are going to use for our example is HC05 module. HC05 is an industry standard module. This HC05 is nothing but a Bluetooth transceiver. Transceiver means Transceiver. Transceiver means it is a combination of transmitter and receiver. So HC05 is a Bluetooth transceiver which is capable of transmitting and receiving data via Bluetooth. So that is the first concept that you have to understand. The second, it is very easy to connect this HC05 to any microcontroller device. Why? Because the communication that happens between HC05 and the host device where you are going to connect is by via UART. Now, in our example, you are having your Arduino here. This is my Arduino. Now, I need to connect my Bluetooth module to my Arduino, isn't it? So, this is my Bluetooth module. What is the name of the Bluetooth module? HC05. Now, when I combine this Arduino and the HC05 together, when I add these two together, my Arduino becomes a super Arduino, which is a Bluetooth compatible device. So now together they act as a wireless device. Now question comes, how am I going to connect this fellow to this fellow electrically? This is where the beauty of UART communication comes. Okay, the way in which HC05 is connected to Arduino is by using UART standard, which means the transmit pin of your Arduino is connected to the receive pin of HC05 one way, and the transmit pin of your HC05 is connected to the receive pin of my Arduino. This is the other way. And the ground of the two should be mutually commonly connected. So this is the simplest possible connection. That is the power of UART communication. Once you know UART communication, it is possible for you to connect any UART compatible device to your Arduino and extend the capability of your Arduino. So that is the power that UART offers to you. Okay. So HC05 is typically connected to Arduino device by using UART. So let us see what are the important pins of this particular HC05. Okay, there are totally 6 pins. This is the front side direction. This is the front view, and this is the back side view of the same module. Okay, so this is the chipset that is actually doing the Bluetooth communication for you, and there is a small antenna here. If you flip this pin, to the back, this pin comes here. Okay, so this is my pin number 1, pin number 2, pin number 3, pin number 4, pin number 5, and pin number 6. In fact, in the front view, this will be my pin number 1, pin number 2, pin number 3, pin number 4, pin number 5, and pin number 6. Right. So if you flip this back side, so this one will come to this corner. So the numbering will start from right to left. Now, though there are 6 pins, we use only 4 pins of this for practical scenario. So what are the 4 pins that we use? Pin number 2 is the receive pin, receive data of your Arduino, of your UART communication. So pin number 2 is receive data, RXT. So this pin has to be connected to the transmit of your Arduino. Okay, so that is pin number 2. Pin number 3 is the transmit pin, TXT. So this pin has to be connected to the receive of your Arduino. And the 4th pin is the ground pin. This pin has to be connected to the ground of your Arduino. And the 5th pin is the power supply pin. This is where we have to give plus 5 volt. As simple as that. Right? Only 4 pins: power supply, ground, transmit, and receive. Rest of the 2 pins we are not bothered. We are not going to use them at all. So let us not worry about those. So these 6 pins, out of the 6 pins, we use only 4. One is power, one is ground, the other one is transmit, and the other one is receive. Okay, so there is a pretty straightforward connection. Now let us see how are we going to connect this to your Arduino. Okay, now so this is my Bluetooth device, Bluetooth HC06. This is my Arduino board. Now I am going to combine these two and convert this dummy Arduino into a super Arduino. So the first thing that I do is I take a 5 volt line and I connect this one to the power supply of my Bluetooth. So I take a plus 5 volt line here. So I connect that to the 5 volt line. So this is my plus 5 volt. And then the second thing is we need to give ground connection. We can take the ground connection straight away from here. There is one ground available here. So that is my ground line. Okay. Third pin is the transmit pin here. So this is my transmit pin. That has to be going to the receive of your Arduino. Arduino's receive pin is D0. So the first pin. This is the receive pin. So the first pin of Arduino goes to this. So the data flows this way. This device HC0 is transmitting data. It is received by Arduino, which is pin number 0 or D0. The fourth connection is Arduino is transmitting data which is received by this board because it is a bidirectional communication, right? So transmit pin of Arduino is pin number D1 or pin number 2. So I take that and I connect it. Now in this case, data flows this way. Arduino is transmitting data which is received by my Bluetooth device. Very simple. The moment I connect this way, now this entire package now acts as a Bluetooth compatible device. My Arduino previously, which was a dummy Arduino, now becomes a Bluetooth compatible device. Okay. So typically this device HC06 would take 5 to 10 seconds for initialization. And now it's time for you to communicate data to this device. How am I going to communicate data to this device? Obviously, you have your mobile phone. In your mobile phone, if you are going to, turn on your Bluetooth, and first of all, you need to install some kind of a Bluetooth app. So this app that I have mentioned here is called Bluetooth Terminal app. This is available in Google Play Store. If you don't want to use third-party mobile apps, it is also possible for you to develop one. Okay, it is not so difficult to design an Android app. Also, as I told you already, if you have small interest, you can do that. But for learning purpose, let us use the already available apps. So this Bluetooth Terminal app, if you download and install from your Google Play Store, this will be looking like this. This will be similar to your UART terminal available in your computer. So it will allow you to send information. It will allow you to receive information. Whatever the data that is coming from Arduino, it will capture and it will display it here. Let us say you have displayed something like in the transmit program, you displayed like hello EAE. If you are transmitting the same thing, it will capture that and display it here. Hello EAE, something like one after the other. So this is the place where it will display the information received from the Arduino. Now, how am I going to send commands from my mobile phone to Arduino? Okay, this is the app sending data to the Arduino. You have a small window here, so you can type whatever you wanted to send. Say I want to send command A, capital A. So you type A here and then click this send. The moment you click send, this device would communicate information via Bluetooth. It is received by this transceiver, and then the communication is sent to the Arduino via the transmit and the receive pins. These two pins are the most important pins. So as far as the Arduino is concerned, one important concept that you have to understand here is, as far as the Arduino is concerned, it is neither bothered nor worried whether the information is transferred via Bluetooth or wireless Wi-Fi or Zigbee or any other Bluetooth, any other wireless standard. As far as Arduino is concerned, information is coming via UART, which means the same program that you wrote for home automation using UART communication will still work for this Bluetooth also. You need not have to change the program, even a single line. Okay, the same UART communication program that you wrote for UART will still work for this Bluetooth also, because essentially the communication happens only via UART. It is only the wire we are replacing. It is only the physical wire we are replacing with the wireless transmitter and receiver here. So program wise, there is no change. The same program that you wrote for UART communication will still work in this case as well. The name of the app is Bluetooth Terminal for HC05. This is available in Android Play Store, which you can very easily identify and install. Okay, so this is not a very difficult thing. You can probably Bluetooth Terminal HC05 is the keyword. So probably this icon will help you out to understand. So this is the user interface for this particular mobile app. Very simple and effective user interface. This place is meant for whatever the data that is received. All the received information are displayed here. And whatever you wanted to transmit, you can transmit from here. So all the commands you can transmit from. So pretty simple and straightforward. And the beauty of this app is this app also offers some buttons here. Button 1, button 3, button 3, button 4. And you can assign some commands for each button so that it will eliminate the repetitive work of typing this and pressing this send button every time. Say, for example, if I assign this command of A to this button, every time if I press that button, A is transmitted out. So if I assign B to this button, every time I press this button, B is transmitted out. So once I assign A and B, so I simply press these two buttons every time to send commands A and B, which will effectively turn on and turn off some devices in the Arduino side. Okay, that will also help you to minimize your typing work and then pressing the send button. So a decent app which will help you to experiment this kind of Bluetooth communication in an effective manner. Now, when it comes to programming Bluetooth, there is no difference between UART programming and Bluetooth programming. Both of them are one and the same. This clarity you all should understand. So initializing UART, transmitting UART and receiving UART is done by using a standard built-in serial object. So initializing UART is done by serial.begin function with a baud rate of 9600. You can use any baud rate. 9600 is the standard baud rate. So that is how I initialize UART. Second one, sending information or transmitting information is done by serial.print function. So you can print whatever you want. So whatever the data that you wanted to print, you can use print function or sometimes print line function. So this would allow the UART to transmit data. So Arduino will send the data out. Okay. Now how Arduino will receive data? Okay. Whether I am receiving data from you standard MAX232 or whether I am receiving data from a mobile phone via Bluetooth. First of all, I should know whether the data is available. So how do I check it? I will put an if condition. If serial.available. What is this serial.available function will return? It will return the available number of data sent by somebody. In case if somebody has given you a data, that will be received by the Arduino. And you are checking whether any data is available to be read. So if that data to be read is greater than 0, whether any UART data is available, you are checking. If that data is greater than 0, then only we are reading. So serial.read. The read function will always return a value which you assign to any variable. So x is equal to serial.read. Then later on you take decision based on what is the value of x. So this is how we transmitted, we received, and we initialized serial port. And we have also did sample projects in the previous class. And so the UART communication and the Bluetooth communication program wise, they are one and the same.